In this video, we studied the chapter number 14, Dual Nature of Radiation and Matter. The new chapter, 14th chapter, Dual Nature of Radiation and Matter. In last video, we studied the chapter number 12, Electromagnetic Induction. Then last point in this video, in last video, that is transformer. We consider there are two types of transformer, step up transformer and step down transformer. Step up means low voltage which is converted into high voltage, that is called as the step up transformer. And step down transformer means the high voltage which is converted into low voltage, that is called as the step down transformer. Then according to this transformer, we derive the formula which is equal to Es upon Ep, which is equal to Ns upon Np, which is equal to Ip upon Is. Means the EMF in secondary coil upon EMF in primary coil, which is equal to the ratio of Es upon Ep, which is equal to the Ns upon Np, means number of turns in secondary coil upon number of turns in primary coil, which is equal to the current in primary coil, which is upon current in secondary coil, means Es upon Ep, which is equal to Ip upon Is, which is also equal to Ns upon Np. So in today's video, we are going to study the photoelectric effect. The Heinrich Hertz discovered the photoelectric emission. Hertz, which is discovered the emission of photoelectric emission while he was studying the working on the electromagnetic waves by the spark method. Then he observed that these ultraviolet rays, means ultraviolet radiation, which is incident on the metal electrode, then the high voltage spark which is passes through this electrode, means this spark which is passes through these electrodes, that means the electrons which is emitted from this electrode, means these electrons which is emitted from this electrode, then means the surface when the electrons are emitted, when illuminated, the appropriate radiation, then these electrons are emitted from the appropriate radiation, then this surface which is called as the photosensitive surface. And these metals like zinc, cadmium, magnesium, which is used for this photosensitive photoelectric emission. Then what is the meaning of the photoelectric effect? Means definition of the photoelectric effect. The phenomenon of emission of electrons, means phenomenon of emission of electrons from this metal surface. Phenomenon of emission of electrons from metal surface when the radiation of appropriate frequency, when this radiation of appropriate frequency which is incident on it, then the emission of electrons from this metal surface is called as the photoelectric. Now the next point is experimental setup of photoelectric effect. What is experimental setup? Means it consists of a practical arrangement of the photoelectric effect, and experimental arrangement means practical arrangement consists of a evacuated glass tube, means photoelectric effect. Experimental arrangement of photoelectric effect consists of a evacuated glass tube. This is the glass tube having quartz window and consisting of sensitive metal plate emitter. One plate is called as the emitter and the other plate is called as the collector. And this emitter and collector plate which is connected to the voltage source which can be varied, means this voltage can be varied. Then also emitter and collector which is also connected to the micrometer, which is then this micrometer which is used to measure the current in the circuit. Then also the voltage, means potential difference between these 2 points, which is also calculated by using the voltmeter, and then potential difference between these two will be maintained. Then the S means this S means monochromatic light which is falls on this emitter. Then initially normally C be the positive potential with respect to emitter, then voltage can be varied, then again the emitter will be positive potential and C will be the negative. Then if the C is positive potential, then they emits the electrons. This is called as the photoelectrons. These electrons called as the photoelectrons, and which emits photoelectrons, and these emitted electrons collects by the collector plate. Means the number of free electrons are present between electrons and collector plate. Means 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 number of scientists was performing the experiment on the photoelectric effect, and they noted some observations. Then the first observation is, when the ultraviolet radiations, means this UV rays which is incident on the metal plate, as soon as if this light is fall on this emitted plate, then current was recorded, and this current was recorded even if the threshold frequency, the frequency of incident radiation is greater than the threshold frequency. Means this nu is called as the frequency of incident radiation, and nu zero means threshold frequency, and this threshold frequency which is different at different metals. Then the second point is, there was no time lag between the incident of light and the emission of electrons. Means there is no time lag between, as soon as the light is fall on the emitter, they ejects the electron. There is no time lag between the emission of electrons, and the photoelectrons started on shining the radiation. Means photocurrent started on shining the radiation as soon as when these photoelectrons stop. Means if the incident radiation stop, then the photoelectrons also stop. Then the next observation is, if the frequency nu, means incident frequency of the incident radiation, and the accelerating potential frequency and the potential which is fixed, then the intensity is increased, and if this intensity is increased, then photocurrent increase linearly. Means if the intensity is increased, photocurrent also increased. Then the fourth point, I was dependent of the accelerating potential. Means this current, here we see if the intensity is increased, photocurrent also increase. Means I dependent on the voltage, means for a given incident radiations. Means current means voltage varied, then current also varied. Means this current which is dependent of the voltage, initially current increased. Means initially current increased with the increase of voltage, but after that it is constant, and this constant is called as, means current is constant, this current constant is called as the saturation current, means I0. Means after some time current means increasing voltage, current cannot be increased, means current can be stopped, then this current is called as the saturation current I0. Then the next point, keeping the accelerating voltage and the incident frequency fixed. Means accelerating potential and the incident frequency fixed. If the intensity of incident radiation was increased, the value of the saturation current also increased. Means if the intensity of incident radiation is increased. Now the next 6 point is kinetic energy, which is depends upon the potential. Means if the potential is higher, then the kinetic energy will be maximum. This kinetic energy does not depends upon the intensity of incident radiation. Means this kinetic energy does not depends upon the intensity of radiation, but if the material is changed, if we change the material, then frequency also change, then also kinetic energy also be changed. But this kinetic energy does not depends upon the intensity of incident radiation, means but the frequency of incident radiation which is greater than the threshold frequency, means incident frequency which is greater than the threshold frequency, then the kinetic energy will be same. Then the seventh point, if the negative potential were applied, means if we apply the negative potential to the collector, then this potential will reduces to zero. This is called as the cutoff potential or stopping potential. Here we consider the three potential and also called as the retarding potential. Here we consider the three potentials and their potential which is retarding. For metal 1, the retarding potential is minus V01. Second material retarding potential will be minus V02 and the third will be minus V03. This is the retarding potential of metal 1, material 1, material 2 and material 3. And then the next point, if the frequency of incident radiation was changed, means frequency was changed but the intensity and accelerating potential be constant, means this accelerating potential and intensity be constant but frequency is changed, then the saturation current will be same. This is the saturation current will be the same but the retarding potential will be changed. Then the next 9 point will be the next 9 point is the photocurrent and the number of electrons dependent on the intensity, means photocurrent and number of electrons depend on the intensity but not on the frequency. But means this photocurrent and the number of electrons depend upon the intensity but not depends upon the frequency, or means in frequency of incident radiation which is greater than the threshold frequency. That means the potential of anode which is higher than the potential of cathode. Means we consider in experimental setup of photoelectric effect, we studied there are 9 observations which is given the sign. Now, the next point is failure of wave theory to explain the observations from experiments on photoelectric effect. Means failure of wave theory to explain the observations from experiments on photoelectric effect. Means all the electrons near the surface of the metal will absorb the energy. All the electrons near the surface will absorb energy. They take sufficient time to require, means they take sufficient time, and after sufficient time they after got the sufficient energy, then they knock off the electrons. Means the metal surface will require reasonable time to accumulate sufficient energy to knock off the electrons. Means they accumulate sufficient energy and after that they knock off the electrons. Means greater the intensity, means if there is a greater intensity, then more will be the incident energy. Greater intensity, energy will be more, and so the time required for the knock off electrons will be less. And for another, means if the intensity will be lower, means lower the intensity, then energy will be less, so the knock of the electron take longer time to knock off the electrons. Means these assumptions which is contradict to the observations, that means kinetic energy does not depends upon the intensity, but here we see the intensity is more, then the knock of electrons is more, so means it depends upon the intensity. This is the contradiction. Then the second point is electrons are free to move inside the metals. Means these electrons are free to move inside the metals. They cannot escape from the surface, but they cannot escape from the surface unless they get the sufficient energy. When they get the sufficient energy, they escape from the metals. Means the minimum energy required to provide it to an electron to pull it out from the metal. Means minimum energy is required to pull it out from the metal is called as the work function, and this work function is denoted as the phi 0, and this phi 0 also depends upon the properties of metals and nature of metals. Properties of metals and metals means this is the 2 points gives the failure of wave theory. Means here we consider means this it depends upon the kinetic energy depends upon the intensity, and also they provide the minimum energy. Then the next video we will study. In this video, today's video we studied the observations of 9 observations of Hertz experiment, and then after the failure of wave theory, to explain the observations from experiment on photoelectric effect. Then